Hi, I am Siddharth. I am here to tell about the discrete mathematics techtalk topic, hoops and fuzzy logic. First of all, what is fuzzy logic? Basics fuzzy logic is logic axiomatization, the family of many valued calculi where the conjunction and implication are interrupted by a continuous t norm and its residuum respectively. In this calculi, O is a primitive truth constant and negation is defined as an and and the lattice meet and joint connectivities are definable. Any continuous T norm can generate using the ordinary sum constructions by only three distinguished T-normals, recursive, Gödel, and product T-norms. Each one gives rise to an important extension of BL, namely L, Gödel G, and product logics. Each such logic is complete with respect to the calculus defined by their respective defining T-norms. A complete algebraic semantics for BL is constituted by the BL algebras, also introduced. In fact, BL is complete with respect to BL chains. That means with respect to linearly ordered BL algebras. In other words, for every formula, one has BL if and only if is an L tautology for each BL algebra L if and only if it is L tautology for the structure of BL chains was studied in where they were shown to be ordinal sums of three special kinds of BL chains. And the second one is hoops. On the other hand, hoops are particular class of algebraic structures which were introduced in an unpublished manufactured by Gucci and Owens in mid 1970s and later investigated in. In fact, hoops are particularly ordered commutative residuated integral monoids satisfying a further divisibility condition. See complete definition in section 3. Hoops and BL algebras are closely related. In BL algebras are shown to be just basic hoops having at least element, and in BL chains were shown to particular ordered sum of linearly ordered hoops, one being the least and having a least element. In this paper, we investigate the falsehood free fragments of the above mentioned logics and we relate them to the varieties of free subregimes of corresponding algebras, which are nothing else than subvarieties of hoops. In particular, we investigate the falsehood free fragments of BL, L, G, and which we call respectively. A complete algebraic semantics for these logics is constituted by basic hoops, by the Weisberg hoops, by the Gödel hoops, and by the product hoops respectively. Thus, we call these hoops hoop logics. We give axiomatizations of all these hoops logics. We prove that they are strong, complete with respect to the corresponding class of hoops, and each of BL, L, G is a conservative extension of the corresponding hoop logic. In a new logic weaker than BL and named MTL is presented. This logic is shown to be the logic of left continuous norms. In several extension of MTL are investigated, and some of them have been shown to complete with respect to the suitable classes of left continuous genomes and their residue. Another complete algebraic semantics for these logics is constituted by the so-called MTL algebras, weaker structures than BL algebras, and which are particular kinds of residuated lattice in which the join operation is defined by means of the other operations, and in which a suitable condition, the so-called pre-linearity holds. In strong completeness of MLT with respect to linearly ordered MTL algebras is shown. In this paper, we also investigate the falsehood free fragment MTLH of MTL. We axiomatize this fragment and we prove its strong completeness with respect to the free subreducts of MTL algebras, which is new structure we call semi-hoops. We also prove strong completeness of these hoops with respect to left continuous genomes and their residue. Then we show MTL, IMTL, and SMTL are conservative extensions of MTLH. This is this is somewhat surprising because it tells us the MTL and MTL plus double negation have same falsehood fragment free fragment where BL and BL plus double negotiation don't. Next, we investigate the logic CHL corresponding to cancellative hoops, the only hoop logic which is not sublogic of can classical logic. And we prove a strong completeness theorem with respect to the class of linearly ordered cancellative hoops. Then we turn the predicate logics. First, we check the predicate logics MTLH, BLH, LH, JHH, and CLH obtained from the corresponding propositional logics MT, LH, BLH, etc. by adding the quantifier axioms for BL are complete with respect to safe interpretations over corresponding linearly ordered algebraic structures. That means linearly ordered semi-hoops, linearly ordered basic hoops, linearly ordered Weisberg hoops, linearly ordered Gobel hoops, etc. Example, BLA is complete. Then we discuss the role of axiom. That means where where is not free. In all axioms of on quantifiers of the above predicate logic were shown to be sound not fully for linearly ordered but also for attributary BL algebras except for we show here that there is a BL algebra and a safe interpretation such that for some is not tautology. Then we prove that logic BLH without is complete with respect to safe interpretation over attributary basic hoops. Similarly, for BL and attributary BL algebras, as as well as for other predicate logics without and for corresponding possibly algebras. Example: MLT and MLT algebras, MT, LH, and basic semi hoops, etc. Even though the proof is easy, this result is interesting because it provides a nice semantics for predicate fuzzy logics without axiom. Next, we show that even in the predicate case, BLH is a falsehood free part of BL and SBL. We also prove that both CHL and is interpretable, polynomial time computable, and BLLG and are CON complete, and since MTL is decidable the logics. By this I am ending my session. Thank you.